Okay, so today I will talk about our recent work, SafeDialBench. It's a fine-grained safety evaluation benchmark for large language models in multi-turn dialogues with diverse jailbreak attacks. I'm the presenter Hongye Cao from Nanjing University in China. And this is my project page and the GitHub page. If everyone have some problem or issues, anytime anyone can contact with me. Okay, let's start. Okay, by the way, this paper is present in iClear this year. So first is the introduction. Uh, let's look like the background. Safety is a critical issue in large language models research and application. Traditional single-turn evaluation only test models against direct request or direct attack. Like this example, we can see that if people just ask some simple questions, the large language models can find and protect itself to do not do harm words. But real-world scenarios always involve more complex multi-turn dialogue risks, like the example in the right. We can see that someone begin with a dialogue, just simple questions, but with the dialogue continue, we can do the jailbreak to let the large language models to generate harmful or dangerous content. Like we just ask them the newly appointed official, and then we ask some financial problems, and then finally we ask to give us some advice to avoid being discovered financial crimes to warn me that I cannot do. Then the large language models will have some dangerous words. So, for the multi-turn dialogues, we should focus on the safety in that scenarios. And the current or existing evaluation benchmarks have do some work in these areas or in these tasks, but they have some major limitations. The first one is that almost 18% or 17% safety evaluation benchmark is about the single round or single turn dialogue. Benchmarks like code or safety bench, they only test the single round interactions. And the second limitation is that they limited attack strategies. Existing multi-turn dial benchmark like Red Queen or CoSafe, they just employ one or two jailbreak attack methods to do the evaluation, and they always limited in single language like Chinese or English. And the final limitation is that there are no fine-grained evaluation framework. Most or the most evaluation benchmark, they do not do a fine-grained safety capability assessment system. They just give one or two scores to judge that the large language model safety under the jailbreak attacks. So based on this analysis or motivation, we want to build a multi-turn dialogue evaluation benchmark, and we want to build a fine-grained evaluation framework. And we can see that SafeDialBench, it contains uh, 4,000 dialogues, and it include two language, Chinese and English, and the turns include including from 3 to 10 turns for evaluation, and our dataside scenarios have 22. And we employ 7 jailbreak attack method to build this datasite for evaluation. Also, we have do a multi-ability evaluation framework for evaluation, and we conduct a model judgment and a human judgment to make sure that our evaluation is good. Okay, let's look at the framework. Is our framework figure, and it has three parts. First is the safety categories. We build six safety categories. It includes privacy and morality, aggression, legality, fairness, and ethics. Uh, in existing benchmark evaluation benchmarks, they always focus on the aggression or fairness. They do not consider like ethics or morality. So we want to build a more safety evaluation categories. And then based on these safety categories, we do the data construction. So for the data construction, we use seven jailbreak attack methods, like scene construction, purpose reverse, and the role play. And I will talk about the data construction process in detail after that. And in the data construction, we include 22 dialog scenarios because we want our data set include more general scenarios that were in human society, like the daily life, travel, employment, and other scenarios. And based on the safety categories and the data construction, we build maybe we think a good evaluation data set. So based on the constructed data set, we do the evaluation. Okay, so the evaluation we build a fine-grained safety evaluation framework. It consider three parts. First, we want to identify unsafe risks, and then after identify unsafe risks, we want to handle unsafe content. And if the large language models can handle unsafe content, we continue to consider the consistency. We want to evaluate the models. Can the models be consistent under the monitor dialog jailbreaks? And then, based on these three aspects, we conduct large language models evaluation and the human judgment to judge the safety from these three aspects. And it's the whole framework or the whole learning process or building process. Okay, let's see. The first part is the safety categories. We build a two-tier hierarchical safety categories. The first layer is the six safety categories: ethics, morality, aggression, and other parts. And based on each part, we make the safety categories in detail. Like the aggression, we consider the insects, impolite stares, and other things. We want to make the safety in detail. And based on these categories, we use seven jailbreak attack method to build the data sets. This method contains scene construction. Scene construction means that we talk about with the large language models and we build scenarios like the last I am someone and the large language model may be some other people and we do talk in scenarios and in that scenarios we maybe the large language model can act some things in these scenarios and will do some harmful or dangerous talk. And the second one is the purpose reverse. Purpose reverse jailbreak attack method means that we do the normal chat with the large language models, but in the final round talking, we want the model to generate the reverse aim to in this talk. And the third part is the role play. Role play, this method is similar to the scene construct. Role play means that maybe I'm the hacker or other extremes, and the models be my partner. We want to do some harmful things in this talk. It's like the role play. And the next one is the topic change. Topic change is that we talk about with the models, but we change our topics in this talk and to check the models that can influenced or not influenced by the topic change. And then the next one is the reference attack. A reference attack is the most used method in other benchmarks. They use it or the other words to do the reference attack. And the next method is the fallacy attack. Fallacy attack is the no method that do the jailbreak attack. And the final method is the probing question. Gradually scale the safety boundaries of the sensitive topic test model. So we use this seven jailbreak attack method to build our safety evaluation benchmark dataset. And after the six safety categories construction, then seven jailbreak attack method selection, we now we do the data construction in detail. It have four steps. First is the method selection. We select the evaluation dimensions. Maybe we select the fairness. Then we select the dialog scenarios, and we select the attack method. Maybe the uh, referenced attack or role play. And based on this selection, we do a human craft dialog question design because we want the data set to include more scenarios and more scopes in our talking. So we use some human expert to design first round guiding prompt or questions based on our method selection. For example, if I choose fairness and the dialogue scenarios may be the daily life, and the attack method may be the role play. And I design one question maybe in a fairness scenarios and the daily life environment, and use role play method to build the first round guiding question. And then after first round question design, we do a multi-turn interaction with the large language models and to build the multi-turn dialogues. Importantly, in the multi-turn dialogue construction, the human expert will involved in each round or each turn dialogue question design to make the dialogue good and the logic is good. Then after the multi-turn dialogue interactions, we do a two-round expert review. The expert will check the coherence and the contextual logic and evaluate the jailbreak effectiveness. So after these four steps, we build our data set. After our safety evaluation dataset construction, we want to use this dataset to do the safety evaluation and look at the right figures. It's a multi-turn dialog. We input our multi-turn data to the evaluated model, and we can get a multi-turn dialog. Then, based on the generated dialog, we want to evaluate its safety, and we do the model evaluation. Um, in this evaluation, we have three steps to do. The first, we identify the unsafe risks, and after that, we check if the models can handle unsafe information. Then we check the safety consistentness to check maintaining consistent safety stance. And all these things we'll do by a evaluation prompt, and we will use that prompt to input to evaluated to the evaluation large language models to check the safety score. And moreover, we use that categories, and we use it to the human expert to give the judgment score. And we can get two scores. The first is the model evaluation scores, and the second is the human judgment scores. And we can compare it to make sure the score is reasonable. That's the evaluation process. Okay, let's see the result. Uh, is the main result. We conduct the evaluation in 17 large language models. It contains open source and closed source models. Like the small parameter models like Bytran serials and DeepSeek 7B chat and GLM and larger parameter models like 千问14 14B chat and Bytran serials. And we also evaluated the Moonshot, ChatGPT, and DeepSeek R1. And we can see under the other lines we can see that for example the aggression in this aggression we can get three scores for the evaluation categories. The ID means that identify unsafe ability. HAN means that handle unsafe content, and CUM means that consistency. So it's our fine-grained three ability safety evaluation, and we can get the scores. Also, we evaluated the attack successful rate. We can check that by trying to 7B chat gains the highest ASR rate, ASR score. It means that it has the poorest safety performance, and the DeepSeek R1 got the lowest score. It means that it has the good safety performance, and that's the main result. And we can see this figure is the agreement between human expert and the model evaluation results. We can see that for the human expert evaluation and the model evaluation, we can get more than 80% agreement. It means that our evaluation framework is good. Is good. And the next result is about the multi-turn dialogue performance. With the turns grow, we can see that like in second turn, the score may be high. It means that the model's performance is good, but with the turn growth in the fifth turns and or in the fourth turns, we can see the score is lower. It means that our jailbreak attack method have good performance to jailbreak the models to generate unsafe content. It verify our jailbreak attack methods effectiveness. And the right figure result, we can see we use two models for evaluation is the Bytran 2 series and the Qianwen chat series models. We compare with different parameter models like 40B and 7B chat. Uh, the conclusion is that the safety will not influenced by the parameter scores. It doesn't mean that a small model have good safety or big model have good safety. It will not influenced by the parameters. Okay, and this result is the performance of different jailbreak attack method. There are some conclusions. The first is the performance difference between models. ChatGPT and Moonshot typically score slightly higher across multiple attack methods and evaluation metrics, demonstrating relatively robust performance. And the difference in the effectiveness of attack methods. In certain chats, the scoring point for reference attack and purpose reverse may be positioned relatively inward, indicating that this attack may be more effective against certain models. That means that through our experiment, we can find that the fallacy attack and the purpose reverse, these two methods have good jailbreak attack performance. And under this attack, models have lower safety score. We can see that in this figure and the other one, other thing. Yes. And I list here the impact of evaluation dimension. The model scored highest in identify, indicating they are relatively adept to recognizing improper requests. However, these scores generally decline in handle and maintaining consistency, where they face the greater challenge. Okay, here I want to explain that why we do the fine grained or we design these three safety dimensions because other safety evaluation benchmarks they just want to get the one score, maybe the generated response safe or unsafe, but models do the safety or conduct the safety. Maybe first they first identify the safety. If they can identify, then they need to handle this unsafe content. Then after that, in the multi-turn dialogues, they should keep their consistency under the multi-turn jailbreak attack. So we did based on this insight, we design this safety evaluation framework. Okay, it's another result because our data set includes Chinese and English, and we just use the English data set to conduct a safety evaluation, and we find uh, a conclusion is that for the Llama 3.1 8B instructor model, it have the poorest performance in safety. And I think maybe this model is not is an unsafe model. We think, and but we can find that the Chinese constructor model E 34B chat models it get the highest score like in morality and privacy, and other and ethics and legality is good, and we can find that this model is good in safety, especially for English data site. Okay. So this is my presentation, but our paper have a lot of things I do not mention here. Maybe we can see the paper or talk later.